Yep, hello. Hello, everyone. I'm Ray. I'm a software engineer here at Parallels. And in this talk, I'm gonna show you how to read query plans and how to build proper indexes for your tables. Okay. Okay. So for the scope, just gonna focus on the Postgres query optimization. But this should translate well in other relational database like MySQL. For broader topics like schema design, like, partitioning, and uh, the sharding, I recommend reading the book from Andrew Atkinson, High Performance Postgres for Rails. All right. Um, so for this talk, I'm just gonna focus on one simple table. So it's called bookings. So think of it like uh, an app, so like Airbnb or other booking services. So it has reference to the client and the agent, and then it has multiple status. So by default, it was pending. It can also be confirmed or canceled. And then so for this, then I'm seed that I create a seed for 120 million rows, simulate production data. And then for the distribution, we have 5% confirmed um, bookings and then 85% pending. So 5% is about 6 million hours of confirmed data. So let's start with a simple query. So this gets the continuous confirmed bookings with this query. Now, of course, we need to add the limit. So it simulates real production. We try to run. So if you want to run the SQL, I'm sorry, the ActiveRecord command in code. Yes, yeah. Just gonna type. Yeah. So if we run it in Rails console, as you can see, it takes a while to run. Um, so so first instinct, if we, sorry. So the first instinct for when we have slow queries is to add an index. So in this case, since we're using status here, so maybe putting an index in the status column will work. But as you can see here, it will the Postgres query planner will ignore those queries. Sorry, this index because the status has the status confirmed is about 6 million rows. So you can so for debugging slow queries, we can uh, use the explain method in Rails. So this will translate directly in SQL. So for example, we can use the explain here. Explain. And so this will not run the query. It will just use the table statistics to give us the expected query plan that Postgres will run. So if you want to get the actual time for the query, you can use analyze. Um, and then I also like to add buffers just to see the cache data. And buffers here. So by the way, this will only work for Rails 7.1 and above. So if you're using Rails 7, okay, right? Do this. As you can see, it shows the query plan and the actual time takes to run the query. Now, as you can see, there's a lot of text in the query plan. So in order to read the Postgres query plan, we need to a good guideline for reading query plans is to read bottom up and then inside out. So basically, the arrow here is one block. So we should start with the last block here and then the second one. So in this case, so what it does is it run a sequential scan on the bookings table and then it filtered up using the status column. As you can see, there's a lot of rows being filtered out. So this is a good suggestion that there's some inefficiencies with the query. And then the buffers here, so it means it's already in memory, and then read, it means that the Postgres needs to query the data in the disk. So as you can see, we also have the rows. So this rows means the data in returns. And then since we do an order by, yeah, we do an order by here. It also needs to sort data. And then lastly, we add limit here. So as you can see, the resulting rows only to 20 rows, but it queries all of the data from the bookings table. Right. So in order to appreciate more the query plans, let's look at how Postgres stores its data. So
was that somebody on Zoom that spoke there?
So again, in order to appreciate more of the query plans, we need to know the how Postgres stores its data. So this is a very general overview of the internals of Postgres. But essentially, Postgres will store the data in a heap, and then it slices the data by pages. So like one page is about 8 kilobytes in size. So if we have 120 million rows, we will need 1,500,000 pages here. And then for each page, it has tuples. So tuples is the actual row in the database, in the table. An interesting note here is when you update a data, it will not remove those the old tuples. It will just store it in the page. It will only mark it as dead, but it's still in the pages. And then also, if you add an index here, it will store it in another data store, another data structure. So the default type of index is the B3 index, as you can see here. So for confirm, it added a pointer to multiple pages where confirm the row is found. So that's how Postgres stores. Also, an interesting note here is essentially Postgres has three-part structure. So first is it will parse these SQL query, and then it will create a query tree. This is also where it checks if the SQL is planning. The next is the planner. So this generates multiple plans, and then Postgres will pick the cheapest plan, and then the third one lastly, it will execute the cheapest plan. So since Postgres is open source, we can actually see the actual implementation of the cost, how Postgres calculates its cost. So for sequential scan, so this is the CE source code of Postgres. The most important part here is the return. So as you can see, it calculates the cost of sequential scan by the startup cost, and then the CPU, and then the disk cost. And then this is the calculation. It's more complicated, but the same structure.
Do you do some work in C?
But the source code of Postgres is actually very, you can explore it. So yeah, so that's how QueryPlanning works. So but the most important thing here is that Postgres will create multiple plans, and then it will pick the cheapest plan, and then it will run. Now there's some you can influence the planner by one updating the statistics, because sometimes it becomes stale, so you can use analyze to update the statistics, and then after blocking points was recommended to running analyze. Right. So what actually works in our regional query is to add a composite index. So in Postgres, it's called multi-column index because it has multiple columns. So when adding a composite index, it's important to know the order. So order is very important. So the guideline is to always add the equality first. So in this case, since our query gets all the confirmed data, so the status should be first column, and then range. So range ranges. So that's the second column. And as you can see, compared to the original, when we create a single index here, where it use sequential scan, now it adds run the query by index scan backward because it use the newest bookings. And as you can see, it only took 40 milliseconds as opposed to 8 seconds.
That was how many rows?
120 million rows.
That's to search for a specific row within an indexed column.
20 US
20,
US bookings.
20 US.
US
Oh, newest.
yes. If so, if we read the query plan here, so again, start at the bottom. So it scans the index here, and then after scanning the index, it's actually pulling the data. So since it has the index here, since we have an index here, it will get it has a pointer to the page, so it will pull the page where the confirmed status is. Works. Okay, second query, so a little bit more complicated, but still manageable. So selecting all of the bookings column, and then the client's name and address. Again, it took 9.2 seconds in this instance here, and then the solution is again the same column, same composite index will work here because our where clause is the same. Sorry, yeah, status and bookings created. And then do note that in Rails, it will automatically create index for relations, references. So that's that. And then if you have large tables, you can also do partial index. So you just add a where clause in the index, and then it will create a smaller subset of the data. So this
Sorry. I didn't hear the word you said. Create a
index, create a smaller, much smaller index based on the condition here. So in this case, it will only create the index for the bookings that has confirmed.
So it's a scope index.
Yes. So this is very useful if you do aggregates. So if you have a large table, large data that needs to pull, so it's very useful. Also, the fastest way of creating a large table is using index only scan. So let's go down here. So what index only scan is to only look at the V3 table, so V3 index, and so it will skip the actual heap table since it already has the all of the information that it needs. So for example, here, if we only select the bookings created at and created bookings created at, and then the status, it will use the index only scan. So again, it's much faster because it will not query the actual table. All right. So beyond V3s, beyond simple V3s, we have one expression index. So if you if you are matching, for example, email, so you can use expressions or functions here. So for example, you can lower the email, and then it will still create an index. But just note that when you are matching with expressions, you need to match exactly what value the function returns. In this case, if we do lower here, when you're querying it, you should also lower the email. So the first one will work, the second one will not use the index, right? So next is gene index. So this is useful if you have JSON binary column and if you have full text search functionality. So if you do fuzzy matching, it's very useful. So for example, here we use trigram.
JSON be different from like the basic default JSON.
I think it's more efficient. JSON structure than JSON. JSON
from an input perspective, is it different?
Yeah, I think so. Because JSON will store it in string, then this one will store in binary.
So do you have to convert it before you write it to the database, or does the database write it?
But I recommend use JSON as JSON.
It's already being converted.
Yeah.
Postgres does it?
Yeah.
Okay.
Yep. So if you use full text search, if you do fuzzy matching, trigram is very useful. Although note that for searches with 2 characters or less, it will not work since the search will be exponential. So just a note when using trigram. Next is the most important one is when to add an index. So first one, add an index when the features actually being used. So you add it in. So any columns that was added in the where clause, the joins, should be added in the index here, then also the order by. And then do note that index will cost has some cost. So every insert, update, or delete Postgres needs to update also the index data. And then I also recommend to add this extension, pgstat statement. So this will track all of your queries and what query plans it use. So in here, I think it's already turned on, but if you use other data providers, you will need to turn it on. So in the effect of that is that you can create the pgstat user tables here. So if you run this, so we can see all of the tables that has high sequential scan rate. So in this case, we only query the table that has more than 100,000 queries in sequential scan. But do note that when you're starting, when the table is clear, so there's like 1,000 or less rows. So sequential scan is actually the most efficient way of doing the query. So seeing some like 50 scans is normal. Yeah. Then also we can do this query for getting all of the unused index. So in Postgres, you can create the index twice, so with the same column, but different name. So Postgres will allow it, but it's not a useful index. So you can run it here. Then next is yeah. So there's some queries that index will not work. So for example, if you have no limit, so since you are getting all of the data in the table, so there's no point for Postgres to use an index. Second is low selectivity. So this is the same. So if you filter, for example, depending without the limit, it will get 85% of the table. So that's about 100 million rows. So sequential scan will still be used. And then in some cases, if you have outdated statistics for your table, so sometimes the planner will pick the wrong plan. Okay.
Yeah, let's say you're doing like the fastest 20 lines, or no, sorry, the newest 20 lines,
Yeah.
but you've got like 10,000 lines coming in an hour or something. Like, would index, like how does the index, or how do you re-index? Like, how does your strategy work for re-indexing?
So it's actually in the auto vacuum here. So Postgres has a feature called auto vacuum. So if you have, so the default is I think 10% of your total rows. So if you receive 10%, it will automatically clean up the tables. But you can configure that to automatically run this auto vacuum. Yep. And then so some gadgets when debugging performance issues. So first is note that Postgres has a cache. So when you first run the query, it will pull all the data from this. So again, take note that pulling data from SSD or hard drive will be slower than RAM. So Postgres will try to cache those data. So the second time you query the same query, it will be faster. In some cases, it will be much faster. So note that yeah. So always use buffers when debugging the performance optimization. Also, Rails query. So Rails has its own query cache. So if you are debugging from the UI, for example, then the first time it times out, and then the second time, oh, it works. So it might be because of the query cache of Rails.
Where does the buffer get toggled?
Buffer, the Postgres buffer?
Yeah.
It's by default. Yeah. So it was shared by all of the transactions that happen. So insert delete. So That's why it's not the reliable way of caching or getting the performance of the query because it's shared. So it could be flashed by another transactions. So yeah, as I mentioned earlier, so it's possible to have stale statistics. So it means that the query planner doesn't know the real count, the row count of the table. So what you can do is to use analyze. So this is the manual way of doing the update. So use analyze here. So this will refresh the table statistics. Next is vacuum. So vacuum will clean up the dead tuples in the pages. Then again, if you Postgres will automatically runs the auto vacuum if you have 10% of data coming in. Here and then this is some Postgres tuning configs. So first is statement type. So actually the 5 seconds here will depend per app. So in some app it will be low. So for example, if you're doing reporting, it will naturally be more than 5 seconds. But the important thing is you need to add this timeout because by default, Postgres will run your queries indefinitely. So it will fight for resources. So second is timeout. So if you have multiple transactions happening, sometimes the migration will happen, and this timeout will kill all of the waiting migrations if it takes too soon. And then next is the idle timeout. So for example, if you open a transaction in Rails, a Rails transaction, and then it holds the connection for, in this case, 30 seconds, it will kill those transactions. Then this is working memory. This is used for sorting, and then I think also limits issues in working memory. So, yep. So other common ActiveRecord problems. The most common one that was one queries. So use includes to preload the association. Then if you do batching, if you have large transaction, use find each or find in batches instead of using each. And then if you only need a couple of columns in the data, use select. So it will only load the specific columns that you added here. And then always use limits. So if you showing multiple records of the table, always use paginated page. So here I recommend paging, but there's a lot of other alternative to paging. Next is other gems. So PG here. So we're going to show the slowest query and then the suggested index of the whole Rails app, and then Rails PGX test will add rank test for the index usage and table size. Next is annotate. So this is not the original gem. So it's called annotate, but apparently it's not maintained anymore. So it doesn't support Rails 8. Use annotate already. Use Rails 8. And then strong migration. So it will catch dangerous migrations. For example, if you add an index without concurrently, it will block all of the writes of the table. So if you're doing it in production, then your app will crash. So always use concurrent. So for summary, this is the last one. The first read the query plan first before adding an index. Don't guess and don't speculate if you adding a new table. And then not all indexes are created equal. Yet you can use single column index, composite index, or partial index. It depends on your use case. And then when you're creating a composite index, always do the equality first. So so in this example, use status first before the range, which is we created that column. And then partial index, use partial index if you have a lot of data and use aggregates. And then do note that index is not free. So you it will require rights. Then always deploy with concurrently. Again, it will, so if you use strong migration, it will notify you, if you forgot to use concurrently. And then second is so last is do a database maintenance. So in this case, adding pgstat statement and doing the vacuum once a month. And then lastly, when you're debugging, sometimes caching hides the performance issue. So always use buffers when you're doing explain requests. Yep, and that's it. So if you want to know more or dig deeper to like Grail's performance optimization or this book, and then if you want to know all of the explain and yeah, so this one PG Master will has all of the documentation of different kinds of scans, joins, and operations in Postgres. And then lastly, Tombot has a great blog about how to read query index. Yep. So that's it for my talk. Yep. Hope you have any questions.